This is 6.2, which is called logarithms, and um, yeah, this is my coworker, classic coworker. Uh, it's a log that's dancing to the rhythms. Get it? Okay. Yeah, let's just move on. Okay, so I'm going to break up the 6.2 video into two separate videos. One, which is this one, is going to be on the different forms of logarithms, okay? And then the second 6.2 video is going to be on evaluating and solving logs. Okay, so let's start off with the warm-up. And what I'm going to do is I'm just going to do this warm-up in this video, and the next one, since it's about evaluating, I'm going to save that for the next video. All right, so this stuff is a little bit familiar. Now, all I have to do is I got to solve for y, and the way that we do that is we want to make sure that the bases are the same. Now, the bases right now are not the same. So I'm just going to rewrite the 27 with a base of 3. Missing an exponent here though. So 3 to the power of what is going to give you 27? Let's see, 3 to the power of 3 gives you 27 because 3 times 3 is 9 times another 3 is going to be 27. All right. So since the bases are the same, that means that the exponents are the same. That means that in this case, y is going to be equal to 3. Okay, now we write our answer like this. We write down an arrow. This arrow means this indicates that 3 is equal to y. Okay, now why do we have to write it like that? Well, because if someone comes and they start reading your work, they're like, okay, here's a question. All right, see the next step? Yeah, okay, I get it. Okay, you change the 27 to 3 to the power of 3. Okay, that makes sense. And then all of a sudden they go to the next step and they're like, whoa, 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 whoa. Where did the black 3's go? Okay, like why, where, what happened? All right, so this step is actually not equal to this step. They're not equivalent when normally they should be equivalent, like the first two steps are equivalent steps. Okay, so because they're not equivalent, we have to add this little part right here that just says, okay, from this step, we know that these two are the same. Okay, so let's do that on the next side for the next question. We want the bases to be 3 again because I have a 3 right over here. All right, so this one, I'm going to put a 3. Now, 3 to the power of what exponent gives you this gigantic number? The easiest way I can think of doing this is just going on my calculator and going 3 times 3 times 3 times 3 until I get to this big number, making sure that you count the number of 3's that you do that for. So I got 10 3's multiplied together will give you this number. All right, and this indicates that your exponents are going to be the same. So y is equal to 10. Okay, so like I said, I'm going to save number 2 for the next video. All right, so here's a little bit of a reminder. An inverse function of an exponential function. So here we have in blue your exponential growth and exponential decay functions. Okay, so they're both exponential functions. And if we flip them over that dotted line, we get the inverse, which is this red guy. Okay, so the inverse is just taking your y and your x and you're just switching them around. So I got x equals b to the power of y. All right, so again, that red graph is the inverse and it's written like this. The only problem is no one likes it being written like that. Okay, that looks weird. All right, I mean, if you think about it, anytime you've ever written a function, shouldn't y go first? So what we're going to do is we're going to just write it as y equals 2, and when it's written like that, it's going to look a little different, but you're going to get something called a logarithmic function. Okay, so when you have your inverse, that red graph, there are two different forms. The first form is what you just saw. X equals b to the power of y. Okay, and that was a weird form because I don't really like this x equals 2 thing. I'd rather a y equals 2. Okay, so that gives way to what we call a logarithmic form. So it's written like this. Now, how do you know which one is which? The exponential form has an exponent. The logarithmic form has a log. Okay, now the thing that makes your mind kind of blow is like how to switch from one to the other. These two forms are equivalent. okay? But to write one into the other form, you kind of have to just memorize where they go. So the base goes right over here as a subscript after the log. Okay, so it's like a little b, all right? And then the exponent actually goes to the front, okay? And then the answer goes at the back, all right? Weird, right? We'll practice this. It'll be okay. It'll be okay. All right, so another way that you can think about this, in fact, if you really want to write this down, I'd probably write this down in logarithmic form. The inverse can be written like this. So remember, this is just your exponent from the exponential form of the inverse. You're going to write log. B stands for your base, and then this is whatever your answer is. Okay. Now we read this as the logarithmic of x to the base of b. Okay, but no one actually talks like that. All right, so it's fine if you don't say it like that. Okay, let's try some examples. Write the equation of the inverse. So notice that I have this guy. This is an exponential function. This is like your blue graph, okay, that exponential growth. Now what I want to do is I want the inverse. Okay, so I have to write the inverse in the two different forms. The first form, super easy. All you're going to do is switch the x and the y. Okay, so there's your original, and then bam. I switch the x and the y. That's my first inverse. It's written in exponential form. Now to write it in logarithmic form, okay, it's going to look like this. Take your exponent, put it first, write an equal sign. Then write log, so I know it's in logarithmic form. Take your big number, your base, put it down there as your subscript, and then whatever that answer was is going to go right here. Okay, these two are your inverse functions. All right, so this was that red graph. Let's try that again. Okay, so this is your blue graph. It's the original. It's the exponential function. Now we're going to write the two different forms for the inverse, which is the red graph. The first one is really easy. You're just going to switch the x and the y. That is the exponential form. And then you're going to rewrite it in a logarithmic form. Okay, so that y is first. Take that exponent, put it right down here, y equals 2. Then put log. The base goes as a subscript, and then this guy goes at the end. So it's almost kind of like backwards. And remember, these two are the inverse forms of that original function. Okay. Let's try that again. Like, we're going to keep practicing this, all right? So write the equation of each logarithm in exponential form. Okay, so this is the red graph already, and I want it to be in the other form of the red graph, so the inverse, all right? So let's practice. Now I'm just going to highlight those three parts. I have y equals 2, and I'm just going to get you to practice to write it as x equals 2 in the exponential form. Okay, so x is going to go first. All right, you got your base, and then your exponent is going to be right here. Okay, so let's try that again. So this is the exponential, this is the logarithmic. Highlight those. Okay, so I want that in the other form where x equals 2 is going to go first because that's the exponential form's way of looking, I guess. So x goes first. Then you got your base to the power of your exponent, which is this guy. Okay, now what I'm going to do is I'm going to give you a question where I'm going to give you this guy. I want you to write this guy. Or not. I'm going to do that later on. Okay, let's just practice logarithmics again into exponential forms. All right. This is logarithmic form. Okay. And I'm going to highlight the different pieces. And we're just going to write it. So here's your answer. It is the base to the power of the exponent. Now, this should make sense, doesn't it? Like 3 to the power of 4 equals 81. 3 to the power of 4 is equal to your answer, 81. Okay, so let's try that without all the colors. 7 to the power of your answer is equal to 343. Okay, see? So this is your logarithmic form, exponential form. Okay, now I'm going to give it to you in exponential form. You're going to put it into logarithmic form. All right, ready? So I already know that this is an exponential form because it has exponents. Now, highlight all your colors, okay? Exponent is written first, equals log of your base, okay, base goes down there, and then your answer. Okay, see, your answer is right there. And that should make sense because 5 to the power of -2 is equal to 1 over 25. Let's try again. Okay, so color all of your different pieces. The exponent is equal to log of your base and then to your answer. Okay, so I think we're going to stop it right there. The next video, we're going to maybe get into some evaluating. Okay, so figuring out what logs equal to.